I am now going to hand over to our presenters who will take us through the remainder of this session.
Good afternoon, everyone. You realize I just waved when I was being introduced, so I was saving my special good afternoon to our grade 1 to 3 teachers. And I do wish for you, I'm seeing you and hearing from you for the first time since the start of the new year. So let me just say a happy new year to you all as well. Now today, teachers, our topic or theme really is promoting problem solving and communication skills at the lower primary school level. Let's get right into it. Now, all right. Now, usually, as customary, we normally start off our session with an icebreaker. And this icebreaker is asking you, which is the odd one out and why? Now, here we have a tomato, cucumbers, carrots, and lettuce. Now, I'm going to ask that you respond in the chat. Tell us which is the odd one out and why do you think your choice is the odd one out? Now, I see the chat is lighting up, and so
Miss Adams is saying that the carrot is the odd one out. Also, Tasha Brown is saying that the carrot is the odd one out. Heather Richard Stevenson is saying it's the cucumbers. The chat is lighting up. Dacian is saying that is the carrot. Shamar Wright, tomato. Stacy and Campbell, lettuce. Melanie is saying the lettuce is the odd one out.
All right, so we have varying responses coming from a number of our participants here, and that is quite interesting. Now, the question is, which is the odd one out? Yes, and I'm sure that a number of persons just identifying the odd one out, but I'm more interested now in why did you say the carrot, the tomato, the lettuce, or the cucumber is the odd one out? I'm seeing some responses where persons are saying that carrot because it's a root crop, and I'm seeing where someone else is saying it's the lettuce because it's the only one without seeds. I also see that persons are saying that tomato is a vegetable, while another person is saying tomato is a fruit. So we have varying responses. Now, coming from this activity, you'll recognize that depending on your choice, you should be able to validate why or justify your choice. And that is a good skill for us to develop as teachers, as well as something we want to develop in our students. Let's try another one. In this situation, I want you to also determine which is the odd one out and why. And this time I'm particularly looking out for you to identify the odd one out and state why it is the odd one out. Now, while you're looking at it, A has a building that appears to be 3 floors. B has a building that is it's a single floor. C, another single floor, and D. Now, why do you think? The chat is lighting up again.
Mr. Williams, we have persons who have raised their hand.
Yes.
Parchment, you can go ahead and respond.
Yes, welcome, Parchment.
Parchment. You can go ahead, share your response. Small, you can share your response. You're unmuted.
I would say C is out because it's the only building that has curved lines.
Okay, very interesting. Do we have any other hand that is raised that would like to?
Howell,
Yes, Howell.
you can go ahead.
Okay. Good afternoon, everyone. I'll say red because in these shapes or buildings, we can see square coming out of all the others, but there's no square coming out of the red shape.
That's a very good observation. Now I recognize that other persons are also, well, he's saying
And
D.
one more reason.
Okay, go ahead.
Red is a primary colors, while the others are not primary colors.
Okay, what are the other colors we're seeing here? We have
A secondary.
yellow.
The others are secondary color. It's yellow or orange.
Okay, and we have a blue here, right?
Blue. Oh, my phone is showing orange, purple, red, and green.
Okay.
That's the colors I'm seeing. So the others will be
depending.
secondary color.
All right. That's a good perspective too, because what you are seeing might be a little bit different from how we are viewing it. And that's interesting to note as well. Now, I also recognize that we have varying responses for these, and persons would have identified the one they think is the odd one out. And of course, again, I want to highlight that any of these three options could be the odd one out, depending on how you are able to validate or justify your thinking. So A, a third floor building, only building that's third floor, and B, the only building with a roof. C, as someone would have said, probably is the only round building, and D is simply a 2D figure.
Okay, Mr. Williams, we have some other responses in the chat. I see Reynolds, Rachel Reynolds, she's saying C because red is a primary color, and she's agreeing with the person who spoke before. Carissa is saying D because it's not three-dimensional. Kedin is also saying D because it's not a solid.
All right.
Nicolene is also saying C because it does not have a vertex at the top.
All right.
And we have Peter Gay Fletcher who raised her hand. We'll now unmute her and allow her to share.
Okay, Miss Fletcher.
Go ahead, Miss.
Proceed.
Good afternoon.
Good afternoon.
So I was saying D also because D is not a 3D shape. It's two-dimensional.
Okay. And thank you for your responses, teachers. As you can see, again, everyone chose, well, a lot of persons chose different answers and were able to validate and justify their own thinking. So again, with an activity like this, anyone could be the odd one out once you're able to justify your thinking. Right.
Mr. Williams, we will take another response. Nicole Clark raised her hand. We'll allow her to share her response. Go ahead, Miss.
I just want to ask if you're seeing my answer in the chat because I have responded, however, I did not hear my response. So I said C because it has no sides.
Okay, C because it has no side. All right, that's a very good observation too, and we acknowledge your response as well. All right, teachers, bear in mind with us that even though you are responding in the chat, there may be 100 chats going on at the same time. So we may not be able to read all the chats all at once. All right, but do respond because we really appreciate your responses. All right, Now, the objectives for this session really is to accomplish the following, right? And these include to promote the importance of developing problem solving and communication skills at the primary level. We also want to support our teachers in implementing problem solving as an approach to teaching. We also want to highlight various strategies to improve the communication and the problem solving skills at grades 1 to 3. Now, on screen, big question. Now, my question to you before I had this up was, are you aware of the mathematical domains as assessed by the Student Assessment Unit for PEP? Now, how many domains are there? There are actually 4 mathematical domains, and these include concepts and procedures. Now, you may ask, what is concepts and procedures? And concepts and procedures is really what the students are being measured towards, right? Which means the students are being assessed as along their content and the concepts, and these are not limited to definitions. Now, when we talk about problem solving, we also want to highlight that it's a student's ability to navigate through novel situations or items that does not have a single entry point to a solution. Now, when we look at modeling and data analysis, this speaks to the student's ability to represent information in concise ways and work through constraints, such as this example I'm going to be giving you. Now, when we talk about constraints, there are certain questions or items that are designed to in such a way that the students are limited to how they go about responding. And one particular situation could be the students are given a budget to make shopping, and so they can only operate within the constraint of that budget. Now, modeling also speaks to their ability to represent, right? Represent information, represent through tables and diagrams and so forth. Now, the final domain here that is measured is the student's ability to communicate. And again, the student's ability to communicate speaks to their ability to justify their thinking, to agree, to disagree, and so on. All right? So these are 4 domains that are being assessed by the Student Assessment Unit for grades 4 to 6 students. Now you may ask, why the domains? Why are we grade 1 teachers being informed or being given information about this? Now, we want you to become aware of the domains that are being assessed at the grades 4 to 6, right? And the emphasis, however, is for us to now help to build a solid foundation for the students at the grade 1 to 3 level, so that they can become more proficient as they move across the upper grades, right? And so we have an important role to play in this process as they move along the race. And this is really a button where we develop the students at the lower level and pass them on, and right. So we have to pass that button on in a strong way. Now, are you seeing my screen?
Yes, right. We are seeing the screen, Mr. Williams.
Very good. Now, this chart that is being highlighted here is showing the distribution of the domain, the performance levels in grade 6. Now, this chart was taken from the PEP results of our grade 6 students. And before I get into what this graph is showing, I want to highlight to the right of my chart, there are 4 performance levels too. So different from the 4 domains, there are 4 performance levels. Now, we have proficient, which is the standard performance, right? And this is where the students are being measured to the standard in our curriculum. Now, highly proficient students are those students who are performing above the standard. Now, when we take a look at the developing, we recognize that developing students are those students that need some support to get them to where the standard is, while beginning are those students with limited or no knowledge, right, of concepts and procedures, problem solving, and so forth. And
okay,
hence,
before you go any further, Mr. Williams, we have Carissa Gardner who raised her hand. We will allow her to share her response. And so at this time, I invite you, Ms. Gardner, to share.
Ms. Gardner, welcome.
Good afternoon. I am not certain why my hand was raised. I had raised it from when we were doing the shapes and the 3-dimensional stuff, the introductory activity. So my hand is not raised for this.
All right, thank you very much. Now, for the students at the beginning, let's continue. The students at the beginning level here are the students with greater needs. These students would need significant attention and intervention need to be developed for these students. Now, looking at the data set here for concepts and procedures, problem solving, communication, and modeling, we want to observe what this data is saying to us about our grade 6 students. Now, let us couple beginning and developing, right, for each of the domains. Now, if we look at concepts and procedures, we recognize that we have a total of 43 students that are performing at the beginning and developing level. Now, when we take a look at problem solving, we recognize that a whopping 67% of our students are performing below the standard, which is they are pretty much at beginning and developing. When we look at communication, we see an extraordinary number of students, which is 80% of our students that are performing at the developing and beginning levels in communication. Now let's take a look at modeling. You recognize that there are just about 57% of our students that are performing at the beginning and developing stage. Now, when we compare all domains, it is clear to us that problem solving with 67% of our students and communication, which is 80% of our students, they need significant attention and intervention. And hence, again, the importance of this session to highlight and to help our teachers get these students to be at the proficient level and the highly proficient level in these performance levels. Now, before I proceed to the table to come, I just want to give you some inside information as to what I will be speaking about. Now, recently, students were given a diagnostic test, and this diagnostic test was multiple choice. Now, the students' result sheets would indicate level 1, level 2, level 3, or level 4. And so I want to highlight what these levels are. Now, level 4, and let me start at level 4, is an indication of the correct response, right? And the students are able to apply knowledge. The students are able to apply knowledge of the content, concepts in the manner required by the item. For level 3, it is showing that the students would have chosen another response other than the correct answer, but what it's indicating is that the student has knowledge of generalization of the content, right? And the concepts evident, but inaccurately apply themselves. Now, level 2, that means a child would have chosen a response that is apart from the correct answer. And what does this response tell us? Is that the student has basic knowledge of the content and is able to identify relevant topics, ideas, but unable to apply. Level 1, again, would be an incorrect answer because there's only one correct answer with the multiple choice, and that would be the level 4. And level 1 is telling us the student has fundamental gaps or lack of content knowledge, right, for the particular subject matter or content specified. Let's go right.
Before you move on, Mr. Williams, someone is pointing out that there is a noise in the background and it is distracting. I'm not sure if you have a noisy background or something is tapping. You can have that addressed.
Okay, thank you for that feedback as well. I'm unsure where that noise is coming from, but let's see if it gets better as we continue. Now, this table, teachers, is showing performance. It's a performance summary table of our grade 6 students that they did with the recent diagnostic test. And I want to draw to your attention the one that I've highlighted in bold. And this is the cluster problem solving, or in this instance, we call it a strand. Now, if we take a note, 16% of the students would have selected the choice at level 1, 27% level 2, 30% level 3, and only 27% of the students in the cohort of students that were sampled selected the correct response, which is an indication that 73% of our students did not choose the correct response for problem solving. Now, if we compare this to the other strands that are highlighted, you will also recognize that problem solving seems to be the area in which most of our students are having the greatest challenge. And hence, we want to help to improve this as time goes by. And one means is to help our teachers, to help our students to improve their problem solving skills. Now, before we proceed, I would like to turn your attention to our next presenter, my co-presenter, who is Miss Tennant. Miss Tennant.
Good afternoon again, everyone, and welcome to our presentation on problem solving and communication. I will be taking over this segment of the presentation, which will discuss problem solving in the classroom. But before we get into this segment, let's take a poll. And the question for this poll is, what is the main role of problem solving in your mathematics classroom or in your mathematics lesson? So you may go ahead and choose, is it an introductory activity? Is it an exploratory activity? Is it only used as an assessment or not, or hardly utilized? So far, 3% of all the participants have voted. We have 25 seconds remaining, 25 persons. The participant list is increasing. 42 persons have already responded. We are cutting this off in the next 17 seconds. So 79% has already responded. 10 seconds to go. 5 more seconds. So we're going to end this poll right here. So based on the responses, we can see that 13% of you has said that you use it as an introductory activity. 81% said you use it as an exploratory activity. 5% said they use it as an assessment, and 1% said not or hardly utilized. So based on the results of this poll, I can see that majority of you use it in your classroom. Majority of you incorporate problem solving in your lesson in some way or form, and that's good. So what I want you to do now, as we go through the remainder of this presentation, I invite you to take part in the discussion that we're going to have and see if you would keep or change your current view based on the information presented to you. So now, you said that you've used problem solving in your classroom. Let's talk. What is problem solving in mathematics? What does problem solving in mathematics mean to you? So I'm going to implore you to raise your hands, and we'll open up your mic so you can share with me what is problem solving in mathematics, as well as you are free to respond in the chat with your responses. So I repeat, what is problem solving in mathematics? Would anybody like to
Miss Tennant, I'm not seeing any responses as yet.
Okay, so I'm in the chat.
I am now seeing a response from Miss Ruby here. She's saying allowing students to think critically. Sasha Gay is saying reasoning.
Okay, good. And these are all components of problem solving. So let's go deeper into it a bit. Problem solving is allowing students to engage in a task or a problem that the solution method is not known in advance. So when we give students a problem solving task, this is a task that the students don't initially see that as algorithm is to be used. This is a task that the students don't initially see that a formula is to be used. They have to critical think. They have to reason in
Ms.
order
Tennant,
to... Yes?
Before you go further, just want to point out that Miss Joan Blake would like to share something. Miss Blake, you can go ahead.
I just entered, I'm not sure what happened.
Okay, so I was saying that problem solving, engaging in a task that the formula or the algorithm or the solution method is not known in advance. But why do we problem solve? Why problem solving? Now, in ancient years, you would have known that the set of tasks or the set of jobs that our ancestors do requires the same set of procedures or the same set of steps. Now, that has shifted in today's society. The jobs that we now have or the jobs that we desire requires us to think, requires us to reason things critically, and that is why problem solving is important.
Miss Tennant?
Yes, go ahead.
I think Miss Allen, there's a Miss Allen who would like to share. Miss Allen, you can go ahead.
A pleasant afternoon, all. Are you actually hearing me?
Yes, we are hearing you.
All right. So, not sure if you went ahead with the problem solving. It actually refers to a mathematical task that have the potential to provide intellectual challenges of enhancing students in mathematical in understanding and development.
Thank you for that response. Thank you very much. So as we continue, yes, you are correct. As we continue, problem solving does three basic things. One, it promotes critical thinking. So it builds inquiry and reasoning skills. It also gives students confidence with tasks. Giving students problem-solving tasks help them to grapple with different novel situations, therefore promoting a positive attitude towards mathematics. Problem-solving also helps students to solve life challenges. So it gives students a tool they need to solve real-world problems. Now, let's move further. Let's look at some of the importance of problem solving in our everyday classroom. The problem solving allows learners to, one, it allows learners to reason mathematically by exploring mathematical ideas. That is, forming an opinion, forming a conclusion, and thereby justifying that conclusion that they have formed. It also allows learners to reflect on the nature of inquiry in the world of mathematics, as well as reflect on and monitor their own thought processes. Let me stop right here a bit. When students are able to reflect on and monitor their own thought processes, they're able to work at their own pace. They're able to carry out Poya's 4 steps of problem solving effectively. So they're able to, at their own pace, understand the problem, at their own pace, search for a solution method, also work with that solution method, then they're able to reflect on whether or not the solution they come up to is the correct answer, or if they need to rewind, if they need to go back and use another solution method to come to their conclusion. Learners.
Senna, just before you move to the next point, persons are having great difficulty hearing you. Maybe you need to speak a little louder or adjust your volume so that we can hear you clearly.
Okay, I hope you're hearing me a bit better now.
Yes, yes, it is.
Okay. Problem solving also allows learners to connect mathematics they learn at school with its application in their everyday life. So when students are able to work through different problem solving tasks, when they meet up problem solving tasks in their real world everyday problem, they will know that in order for me to solve this problem, I need to reason critically, I need to think, I need to investigate, I need to explore, I need to do all of these things in order to solve the problem that is at hand. And last but not least, problem solving also allows learners to make connection between mathematics concepts. So let's look on some cases. We're going to investigate at this moment. Which case do we think will create better problem solvers? And I want you to work with me because we're going to discuss. So in case A, and this is the teacher talking now, in this lesson, you will learn how to divide. If we have the math problem 12 divided by 2, it means we should divide 12 into 2 equal groups. So here is where the teacher demonstrates how it is done. So the teacher has the 12 triangles in one box, and then she shares them into equal groups, into 2 equal groups of 6 each. The teacher then moves on to give students 2 similar questions that they should solve using the same method. So my question to you, teachers, What knowledge do you think the students would have gained from attempting case A? And you may raise your hands again so that we may unmute you, as well as you may also respond in the chat. Going through case A, teacher finished teaching the skill. What knowledge do you think the students would have gained, the students would have garnered from attempting case A? Mrs. Cohen, is there anything in the
Miss
chat?
Tennant, I'm seeing where Miss Pinnock is saying fraction of sets.
Okay, good.
I'm not seeing any other responses as yet.
Okay, so from case A, you would have realized that the teacher used a specific strategy.
Ms. Tennant, there are some other responses. Cheryl Grace saying divided objects into 2 equal groups. Krishna Foster is saying grouping, as well as Dana Lewis. She's saying grouping as well. Dion Francis, fractions, as well as division. Nicole Martin, sharing. So I'm seeing quite a bit of sharing and grouping and partitioning. We also have Nicole Martin, who raised her hand. We'll now allow her to share. Go ahead, Miss Martin.
It was actually an error. I'm sorry. It was an error.
Okay, thank you. And you would have all been correct. Students would have learned how to share, how to group, and all of that. So the teacher uses one main strategy, one specific strategy to bring across the concept to the students. The teacher really didn't give students a chance to think about anything. This now limits the students' analytical as well as their reasoning skill, because the teacher is basically showing them what to do. She's basically telling them what to do, then giving them similar problems to solve. But before we say anything, let's go over to case B and see how case B differs from case A. Teacher gives students the following scenario. Mr. Black bought 12 birds. He wants to place them in cages. The same number of birds should be in each cage. How many cages are needed? How many birds will be in each cage? The teacher probes students by asking guiding questions as they use different strategies to solve the problem. The teacher then asks one of the learners to explain how they solve their problem and invite other learners to ask questions and to propose alternatives. So in case A, we see that the teacher gives students a little scenario about 12 birds and they need to divide it into equal groups. While the students are working, the teacher asks some probing questions, asks some guiding questions to help them to use their different strategy to come to a conclusion and to come to an answer. The teacher then opens the floor for a discussion where she also invites other learners to give other solution methods that they could have used. So let's role play. Let's imagine that we are the students. What are some of the answers you think students would come up with? So I'm going to allow persons to communicate with me. Raise your hands and I'll open the mic, as well as be free to respond in the chat.
Yes, I'm seeing where Melissa Smart raised her hand. We'll now allow her to speak. Go ahead, Ms. Smart.
Good afternoon, colleagues.
Good afternoon.
Good afternoon.
For case B, which I like, the children are given the opportunity to explore. And then in exploring, they'll be analyzing the situation and so on. So you'll get varying responses, right? So you may find the students giving different answers based on how they group the birds. So for example, the students may be sitting in groups of 4. So they will try to share different amounts to each other, or different number of things representing the number of birds to each other. So they'll come up with different answers. So they may give, say, if they're in the group of 4, they may give each other 3, because they'll share, the counters are so alternately. So they'll see that when they're finished sharing, each person may have 3 and so on. They may put themselves in pair and do the same and see that they get different numbers. So they'll be able to explore on their own and create different grouping instead of the teacher giving them exactly what to work with.
Okay, thank you for that. Is there any response in the chat that you'd like to share, Mrs. Cahoon?
Before we go to that, there is a Deandra Dixon who raised her hand. We'll now allow her to share her response. If not, we'll take some more
Good afternoon.
responses. Okay, go ahead, miss.
I'm just responding to how many cages are needed. A possible response would be 3 cages with 4 birds each.
Okay, thank you very much for that response. Is there anything in the chat? Mrs.
Yes,
Cahoon?
I'm seeing where quite a few persons would have responded in the chat. We have Chevin Wilson saying 4 cages of 3 birds or 3 birds of 4 cages. We have case B. Ewart Gailey saying case B is more student-centered. Students are allowed to investigate possibilities. I'm seeing where Yvonne Codner is saying 2 groups of 6 cages, 2 birds, 3 groups of 4 cages, 3 birds. Dennis is also saying 3 birds, 4 cages. I'm seeing where Nicole Martin is saying students can see the relationship between division and multiplication. Samantha McKenzie says 4 cages, 3 birds. And Nicole Clark said 2 cages with 6 birds.
Thank you. So let's move on to the other slide to explore some of the answers that you would have given, that the students themselves would have also come up with. So these are some of the possible solutions, and you would have written it in the chat or you would have communicated it to me. The students could have 2 cages with 6 birds each, 2 cages, 4 cages, 3 birds each, 3 cages, 4 birds each, as well as 12 cages, 1 cage each.
Okay, I'm seeing some other responses in the chat, Miss. I'm seeing where, let me go. Persons were saying that it can be used to discover the commutative property of multiplication.
Okay, and I have another question for you. How would the impact of case B differ from the impact case A would have on the student? And I'm going to open the floor for one person to just tell me how would the impact be different between the 2 cases?
All right, so you are at Gail raised, hands is raised. Now we are going to allow you to go ahead and share your response. Go ahead, Gail.
Hello?
Good afternoon.
Hearing me?
Yes, we are hearing you.
All right, so for case A, I believe it is more like of a chalk and talk procedure, as where case B, as I had said before, allows the students to investigate the different possibilities. I looked back at it and I also realized that the students are also being exposed to another concept, which is the concept of factors. So they'll know the factors of 12 years. So they'll not just know that 3 into 12 goes 4 times or 4 into 12 goes 3 times, but based on what the solutions here for case B are showing, they're looking at 12 being divided into 2 parts, 12 being divided into 6 parts, into 3 parts, into 4 parts, and even into 1 part. So as I said before, it is more student-centered, and there's a variety of answers that would come from the students.
Thank you very much. And I do agree with you. As we go back to the previous slides where it says problem solving allows learners to link or connect different mathematical concepts. So this topic alone, this task alone can link it back to the other concept of factors. So I agree entirely with you. So case B, let's
just before you go to your next point, there are a few more persons who raised hand. We have Suzette Coombs. We'll allow her to share her response. Then Melissa Smart.
Can you hear me?
Yes, we are loud and clear.
Okay, I was just saying the second way, case B, it encourages active learning. The first way was the teacher just putting it in your head for you. This one now, it encourages meditation, making connections, just as the presenter was saying. So this is a better way. It makes learning much more interesting and let them grasp more things than if we were to just try to put the concept straight into their heads.
Thank you very much. Ms. Smart?
Okay, so I have similar information as Ms.
Ms. Smart? Okay, Seema,
hello? Go ahead now?
Yes, go ahead.
Okay. So the students get to play an active role in the teaching and learning process. Also, because they are allowed to explore and investigate, they get a better understanding of how the ideas are connected. So they more grasp it at a conceptual level, which is for case B.
Thank you very much. And
yes,
I agree with you.
Yes, and in addition to that, there are some very interesting responses in the chat. I see where Nicole Martin, she's saying that it shows differentiation. I think she's speaking to case B, shows differentiation and allows the students to see the different ways to represent the same problem. Amelia Nelson is thinking that case A limits critical thinking, whilst case B opens up a broader perspective with different possibilities.
Thank you very much. And I agree with all of you. Case B, yes, allows students to explore and investigate. When they're allowed to explore and investigate, it does promote critical thinking and it encourages active learning, that is student-centered learning, where they are the one creating their own learning. Case B opens the way for multiple responses as well as multiple approaches or strategies. With case B and with the question you're going to ask while they are working, it can create a rich mathematical discourse through exploration. Also, you will realize that case B is an open task. So students at different levels, students that are considered to be slower, students that are considered to be quicker, will be able to work through the problem, will be able to work through case B. So it will not limit the ability of any student or any students. So a criteria for a good problem solving task, one, and just like case B, it has to be open. It has to be open with no clear, immediate, or available solution process. Students must have a limited ability, limited opportunity to rely on algorithms, limited opportunity to rely on formulas. They should be able to reason through the question to find a strategy, whether or not they're going to work backwards, they're going to do trial and error, they're going to draw their diagrams, whatever it might be. It should have a limited opportunity for them to rely on algorithms. A good problem-solving task must also apply to the knowledge of real-life situations, and it should also have high levels of reasoning required for tasks.
Mr. Nat, before you move on, I see where Novlet Neil shared that students who are more involved will remember more. Students develop skills of critical thinking and collaboration.
Thank you very much. So we want our students to become good problem solvers, effective problem solvers. How do we go about doing that? What's the first step we as teachers need to take? Let me hear from you. Let me hear from the teachers. What's the first step we need to take in helping our students to become good problem solvers?
Avaris Tenet raised her hand. At this time, we'll allow her to share her response. Go ahead, Tenet. If not, we will move along.
Good afternoon.
Yes, good afternoon.
Like the other participant, I am having a little concern. I am sending answers to the chat, but I am not hearing it being read. So that's why I raised my hand.
Okay, with the vast amount of responses, we may not get to read everyone's responses. However, we have noted what you've said, and in our discussion, your point would have been brought out. But thank you for that. So,
we have Coombs, Suzette Coombs, who raised her hand, as well as Lisa Strong. We'll allow Coombs to go first. Go ahead, Ms. Coombs.
Okay, you asked what challenges can there be to us having this kind of approach in our teaching? If a child can't read on his own, that's one of a big problem, because it means he will have to always wait on someone to read and help him interpret. So reading level has to be addressed, and the confidence of the students. We have to work on building their confidence too.
Thank you very much.
Before you move on, Ms. Tennant, I'm seeing where Teresa Thompson is saying move from rote learning and teaching. I'm seeing where Shamar Wright is saying ask open-ended questions. Nicola Bramwell shared that as teachers, we have to make the students comfortable with the subject, bring it to a real life experience. Faye Phillips is saying one of the first things should be is to find out where students are and then help to develop the child. Here we now allow Lisa Strong to share her response. Go ahead, Ms. Strong. If not, we will move along.
Good. The responses I heard were the responses I heard coming from the chat or coming from you while you spoke was that we need to incorporate problem solving in our lesson. And that is what we need to do. We need to teach through problem solving. So teaching through problem solving involves engaging students in different problem-solving tasks, using problem-solving as the medium, as the central point through which we teach students different mathematical content. When we're teaching through problem solving, we allow students to learn mathematics by solving mathematics, by solving problems. We allow students to grapple through different novel problems, present and discuss different solution method, and together build concept in the mathematics curriculum. Now, teaching through problem solving is entirely different from teaching for problem solving. Some persons would have just basically do rote learning, basically teach Then after which they give a problem-solving task as the evaluation activity. We want to shift from that. We want to instead teach through problem solving. Give students various tasks that they can explore, they can work through within their classroom, share ideas so that they too can learn from their classmates. But as we teach through problem solving, what are the roles that teachers must carry out? And I know that during your years of teaching in the classroom, you would have been carrying out some of these roles. But in order to advance, let us really go through them. Let us really revisit them and to see how best we can help our students to become effective problem solvers. So now the roles, the teacher's roles are in direct relation to the teaching practices. And you would have been aware of the 8 teaching practices. Now, the first thing a teacher needs to do, a teacher needs to implement tasks that promote reasoning and problem-solving skills. They need to choose tasks that are built on current students' understanding, have various entry points with a variety of ways they can solve the same problem. Let's look back at case B. Case B is a novel, real-world type of task. Case B allows students to explore. Case B allows students to investigate. Case B allows students to reason. Some form of critical thinking needs to be done in order to get the answers or the solutions. Now, I know that some of us may not be teaching face-to-face, and we may be asking, how are we going to do this? Using your WhatsApp groups, you can send your students the different tasks in your WhatsApp groups. You can present using Zoom, or even if you're face-to-face, present the idea, present the task in such a way that students are able to reason and critical think. While as you give them the task, it is important that you guide students to use and connect mathematical representations. So that is, we're going to encourage our students to use the different concrete models, to draw what they're thinking, to represent what they're thinking, whether it be using the different virtual manipulatives, whether they're using words, whether they're using their hands-on manipulative symbols, whatever it might be, they should be able to represent what they're thinking. And this can be done in the different modalities that we have today. So you can use the different virtual manipulatives that is available on the internet, allow students to show what they're doing, send their working in the WhatsApp or Google Classroom, in different Google Classroom. While they're using and connecting mathematical representation, we should also ensure that we pose purposeful questions. Ask students questions that build on or extend their thinking. So for case,
Ms. Tennant, just before you move on to that next point, I'm seeing where one of the participants is saying, shouldn't the students be first introduced to the different algorithms first before they would be allowed to select the method they would prefer to use in a given mathematical problem?
Thank you for that question. Before we begin to teach algorithm, before we begin to teach students a set method, it is important that we help them to problem solve. Give them a chance to reason through questions. Give them a chance to try and see what they will come up with in order to answer this question. Sometimes our students know, but they need to be given a chance to think. They need to be given a chance to share their ideas before we as teachers try to give them the set of steps to get to their answers.
There is someone who raised her hand, Jacqueline Wright. We'll allow her to share her response just now. Go ahead, Ms. Wright. We are not hearing you, Miss Wright. All right, so we will continue. Go ahead, Ms. Tennant.
Okay, thank you. As we pose purposeful question, let's look at case B. A question that we could have asked to build on or extend students' thinking in case B is, how did you know that that solution method worked? Giving them a chance to explain. What other strategies could you have used to solve the same question? This in itself will generate a meaningful mathematical discourse. So students, we need to engage students in explaining their mathematical reasoning. And this is done by you first asking guiding questions, by you encouraging them to share their responses. While students are working through this question now, we need to support productive struggle in learning mathematics. So a student might be working through case B and you realize that they're not as able to easily get to the answers as the other students. You as the teachers need to encourage that student not to give up. Ask the necessary questions to help the students to deepen their understanding, to help the students to think in order to help them to get to a solution method. And we should also elicit and use evidence of students thinking. So we're going to pose questions and answer student questions that provides information on how they can progress. So these are all the things that we as teachers need to do in order to help our students to become effective problem solvers. Let's go through a lesson that will help you to see how we would teach through problem solving. Now, this lesson is set at the grade 2 level. The topic is fractions, more specifically quarters, and the objective for this lesson is read and write fraction, halves and quarters or fourths only. Now, for the engagement activity, we use the notice and wonder approach. Now, this approach is where a picture is shown to the students. The students will look on the picture and tell what they are seeing, what they are noticing, what is on their mind. Then, after which they will be asked, what do you wonder? Or what questions come to mind just by looking at this picture? So the engagement activity is, students will be shown the picture below. They will be asked to first share what they notice about it, and then what they are wondering about the picture. So let's role play again. You are the students. What do you notice about this picture? What comes to mind? And you share your answers by raising your hand, as well as you may respond in the chat. What do you notice, or what do you wonder about this picture? What do you notice first? So let's talk about what do you notice? What comes to mind?
Melissa Smart raised her hand. Go ahead, Miss Smart.
So I would say that I noticed that the pizza is divided into 4 parts and all 4 parts seem to be the same size.
Okay, thank you.
I see Monique, Brian is saying something is being shared. Dana is saying it's whole. Avery Stennett, it is divided or cut into 4 parts. Therese Somsey is saying it is cut into 4 parts. Lorraine sharing spaces into 4 equal parts. Rachel Reynolds, the parts all look the same size. Cheryl Gray says divided into 4 equal parts. Those are the responses in the chat. We have 2 persons who raised hand. Dana Smith, you can go ahead. Kadeen Smith.
Danny, good afternoon.
Danny, go ahead.
Yes, just a clarification here. I I face this problem with planning my lesson where they say you start from the concrete, the CPA. Whenever I start from this angle where there is a picture, it's always an issue. But this is the second workshop or the second math person that I see starting from here. But I would love some clarification as it relates to starting with a picture and the CPA concept. Concrete, pictorial, and abstract, there's always say we must start from there.
Thank you for sharing that. I'm just gonna just jump right in. So when we talk about the CPA approach, you're quite correct. We want to move from the concrete stage through to the representational or pictorial, where we ended the abstract stage. However, because we're now in the virtual space, we have to modify how we look at things. There might not be always the opportunity to be able to share with students using the concrete resources. So you can resort to utilizing those representation, right? So it's fine. And then because you're also introducing a lesson, it's very important that you understand that because you're not necessarily exploring a new concept, in the introduction, it's more of setting the tone as well as looking at the prior knowledge that students should have. It's not a matter of you starting from scratch. It's just you advancing from where you have left off, really. And that's what would allow for it to fit perfectly in this place and space right now. Hope that answers your question. Or helped in any way.
Yes, it did. Yes, it did. Thank you.
All right, back to you, team.
Okay, thank you.
I've seen some other persons who raised the hand. Dana, Kadeen Smith, you can go ahead. If not, we will take Therese Thompson, followed by Shamar Wright Powell. Go ahead, Ms. Thompson.
Good afternoon, colleagues.
Good afternoon.
Good afternoon.
I was just wondering, couldn't we have given them the pizza in a whole first and asked them how they think we would share the pizza equally between 4 persons? I'm just curious.
Yes, we could. That is a good suggestion. We could start from there, where we give them the whole, and then take it from there, where they share it into these 4 equal parts. Thank you for that response.
Okay, you're welcome.
Thank you for that. But as we go through this lesson, you'll realize that what you just suggested is done. We, however, did it in the, let us go to the lesson and you will see for yourself. So this engagement activity would have set the tone for, wait, I'm moving too fast. Let's continue. We've done what did you notice? Let's now move on to what do you wonder about the picture.
Before you go to that, Ms. Tennant, we have Shamar Powell who raised a hand. We'll allow her to speak before you go to what they are wondering. Go ahead, Ms. Powell. We are not hearing you clearly, Ms. Powell. So we will move right along until that is sorted out.
Okay, so let's pretend again. What do you wonder about the picture? What question comes to mind as you look on the picture? So you're the student. What do you wonder? What questions come to your mind? Again, you can raise your hands and we'll unmute your mic so we can discuss it together. As well as you can respond in the chat. What comes to your mind? What questions come to your mind? So probably, anybody there?
We have Ingrid Pinnock who said shared in quarters. We have no other responses just yet. I'm seeing Deborah Reed saying how many persons will it be shared between? No other responses just yet. I think Marveline was about to, but Carla Dennis is saying share for 4 persons. Deborah Reed is saying, I think she missed out something there. Stacy Clark is saying sharing for 4. Kadeen Smith raised her hand. We'll allow her to speak. Go ahead, Ms. Smith.
So afternoon, everyone. Good afternoon. So if we have 6 persons waiting in line, we could probably ask the students, we have 1 pizza that is cut in 4 equal parts. Of the 6 persons who are standing in line, how many persons would be able to, the pizza would be able to share for? Of the 6 persons, how many persons the pizza would be able to share for? The fact that the pizza is cut in 4 equal parts.
Thank you. Before you go on, Ms. Tennant, the chat is lighting up. I'm seeing where Amelia Campbell is saying, how can it be shared even more? Cheryl Gray says, can be shared for 2 persons. Jaron Rose is saying, I'm wondering how many more slices I can get from this pizza. And Dion Francis is saying it can be shared for 8 persons. Those are the responses in the chat.
Thank you very much. And I really like your responses. So you would agree with me that this engagement activity would set the tone for the remainder of the lesson. It is a means of deepening our students' thinking. So they will be thinking about all the questions that you just gave a while ago, thereby helping with their analytical skills, thereby setting the tone for them being able to explore. So after we do this notice and wonder activity, it is important that we have a discussion with the students. It is important that we try to find out what they know and discuss the meaning of quarters. So we would have a discussion explaining to students, okay, a quarter means that a shape or object would have been divided or would have been shared into 4 equal parts, and each part would have been a quarter. Having this discussion, we would now go into our explore activity where students will be asked to use the template below to provide different ways of representing a quarter. You as the student, describe some of the ways you think you could have represented a quarter using these templates. And we're going to open the floor for persons to raise their hand so we can have a discussion, as well as please don't be afraid to use up the chat option.
Andrika Mullins raised hand. Go ahead, Mullins.
I think I raised my hand from earlier on. I don't know why it's just showing now.
You can continue, Ms. Tennant.
Okay, thank you. So as you type in the chat, we're going to watch a video of how a student chose to represent quarters using the same template.
I know that when a whole is divided into 4 equal parts, each part is called a quarter. So maybe if I connect the lines, 2 lines at the corners here, and the other lines corner here, I should get 1, 2, 3, 4 equal parts. Okay, let's try another method. How about this way? Now there are 1, 2, 3, 4 equal parts. Okay, let's try doing it this way. One, two, three, 4. Good.
Okay, thank you. Is there any response in the chat, Mrs. Cohen?
I am seeing where Tasha Brown shared that they could have folded it half first, then fold it again into another half. I'm seeing where Sandra Williams is saying, I think she's referring to the representation that was done before. So cut it from the corners to get 4 equal shaped triangles. Cheryl Gray saying it can be shared in the shape of triangles. Those are the responses in the chat.
Okay, thank you. Those would be indeed some of the representations that students could have made. Now they've explored, they've tried to reason through the problems. The explain now is where you try to ask them some purposeful question to elicit a mathematical discourse. We could probably ask a student, let me ask you first. We could ask the students, how did you divide your shape? How did you divide your shape? And how can you tell if the shape is divided into equal parts? Now let me hear from you. What other questions could you have asked students to elicit a meaningful mathematical discourse? Now the chat will be opened, so please raise your hand so we can unmute you, as well as you can respond in the chat. What other questions could you have asked to engage students in a rich mathematical discourse based on what they would have been exploring? Okay, so
Melissa Smart raised her hand. Miss Tennant, we'll allow her to share. Go ahead, Miss Smart.
You could ask them, how could you share this shape into 4 equal parts? How?
Thank you. We could have also asked them, what if a child could only do one? What other ways could we have split the shape? You will realize that the students were given a little bit of scaffolding to help them to divide the shape into equal parts.
Miss Tennant, before you go to your next point, I'm seeing where Peter Gay Fletcher is saying she's sharing a question. How many parts does the shape need to be divided into to represent quarters?
I like that question. Thank you very much. So the teacher should ask students questions to generate a rich mathematical discourse, after which we would need to elaborate. We would need to build on the knowledge that they would have garnered from the explore activity. We would need to deepen their understanding, so we would have an extension activity. So for our extension activity, we have students will be engaged in the following activity. Teddy, Alex, Pat divided the squares in the following ways. So these are the ways that Teddy, Alex, and Pat divided their shapes. Which student divided the shape into equal parts or quarters? explain why. So let's talk a bit, let's discuss. Let me open up the mic so you can raise your hands and respond. Which student or students do you think have divided their squares into equal parts or into quarters?
Therese Thompson raised her hand. Go ahead, Miss Thompson.
Good afternoon, Teddy and Pat. Their own is in equal parts, quarters, yes.
Before you go, why not Alex?
Because Alex he only cut 2 in equal parts, and then the other 2 is in another different part. And in terms of quarters, all quarters has to be in 4 parts, 4 equal parts. His is that is now cut in 4 equal parts. But even though Pat own is cut into a unusual shape, it is equal, because if I cut it apart and put them together, they're going to be in 4 equal parts.
Okay.
And so is Teddy's.
Yes, thank you, Miss Thompson. Before you go on, Miss Tennant, there is I see Alicia Brett raised hand, and we'll take her, followed by your Gail. And there are some responses in the chat as well. I'm seeing where Tracy Bennett is saying Pat and Teddy, Francine Lewis, all of them. Tanisha is saying Teddy. Dione is saying all 3. Go ahead, Miss Brett.
Good afternoon. I'm seeing Teddy's own clearly, but yeah, well, Pat, no, yes, I'm seeing the puzzles there, they fit in. I'm not so certain about how quarters would come out there. I'm not certain, but definitely not Alex from my end. Thank you.
Thank you as well. Anybody else would like to communicate, would like to unmute their mics and talk?
Yes, I'm seeing you are Gail. Raise the hand. Go ahead,
All
Gail.
right, so Teddy is clear. Pat, you could say that Pat has hers in quarters as well. But if you agree with Pat, then you're going to have to also agree with Alex, because even though 2 of his parts are of a longer length, if you should let's say arrange them, then they could be equal to one part of the rectangular piece could be equal to the other part of one of the squares, sorry, because if you look at it carefully, you will see where the area of one rectangle would be equal to the area of one of the squares, if you should check it that way.
Thank you. Is there anyone who would like to share?
We have Mitzi Spencer. Go ahead, Spencer.
I concur with you, Gail. And when we look on Alex, I think one of the things that I think comes out from that is equivalent fraction. They are equal.
Thank you very much.
We will take another response. Melissa Smart, you can go ahead.
Okay, so all of them you would say have divided their shapes into 4 equal parts or quarters. But at a first glance, everybody would really choose Teddy because that is so evident, and also Pat. But when you look at it, as 2 colleagues have stated before, when you look at the area of Alex's own, you would see that it's also 4 equal parts. It's just the orientation of how the thing is divided.
Thank you very much.
Thank you so much. And in the interest of time, we'll just take one more. Trisha Bartlett, you can go ahead. If not, we will Ms. Bartlett. If not, we will take Heinz. Oh, Bartlett is on. Go ahead. We're not hearing you, Miss Bartlett. Hines, we will take your response. Instead, Hines, you can go ahead.
Yes, good afternoon, everyone.
Good afternoon.
There are 3 squares, right? And you know, squares, they all have equal sides. Now, when you look at Teddy is distinctly divided in 4 equal parts. The moment you look at it, you will say, yes, that is divided in 4 equal parts. But when you look at Alex, it looks like it is not equal. But what if you draw a vertical line, a line from the top to the bottom? That's where the 2 to the left side. What if you divide that left side, that you draw a line from the top to the bottom? It would definitely be the same 4 equal sides. What if it wasn't a horizontal line? What if it wasn't a line from the left to the right? And if it was from vertical top to bottom, it would definitely look equal. But Alex is equal, Teddy is equal, Pat is equal. It's just that they are shaped in different forms. But if you should pick them out one by one, let's say you have them on paper, and you should pick it out one by one, and let's say the paper, you know, you can change the style in which it is in, and you put them in the same shape, then you will realize that all of them are equal. It's just that they have different shapes. But if you think critically, if you take a second look at all of them, you'll realize that all 3 of them, Teddy, Alex, and Pat, they are all equal. It's just that they are in different shapes, and Teddy is more outstanding than the others.
Thank you very much. And I really like the answer you gave. I really like the questions you used, and I also like how the fact that you're using up your concrete representation to help the students to arrive at an answer. Yes, Teddy, you can distinctively see that Teddy's own is divided into quarters. Pat and Alex, not so much. It is now important for you as teachers to ask the correct guiding questions to help students to see that Pat and Alex's own are also divided into quarters. It's important that you help students to use different representational models to help them to think critically to see that Alex and Pat are also divided into quarters. Thank you very much for your answers.
There is a concern in the chat. I'm seeing where Sandra Williams is thinking that can a child at this level easily determine that Alex's own is divided into 4 equal parts?
So as I said, while it may not be obvious for a child at this level, it is important that we ask the correct questions, pose purposeful questions. It is important that we use the different models, use the different things that we need to use and connect mathematical representations, help them to draw what they're thinking, help them to represent what they're thinking using handmade, hands-on manipulatives or virtual manipulatives to understand or to attempt the question. Some students might not easily see that Alex is quarters. This is where you as teachers need to support productive struggle. Pause and ask the correct questions. So as we come to the end of this segment of the presentation, it is important that we teach through problem solving. It is important that we engage students by using problem solving as a means of teaching mathematical concept. It is important that we implement problem solving tasks in our classrooms. It is important that we use and connect different mathematical representations. It is important that we pose purposeful questions, thereby enriching mathematical discourse, it is also important that when students are struggling, that we encourage them to not quit. And we should also elicit and use the evidence of students thinking. When all of this is done, we will have effective problem solvers. Thank you for listening. I will now turn over to Mrs. Taniel Frisco-Hoon, who will be talking to you more on the communication domain. Thank you.
Thank you so much, Ms. Tennant, for taking us through that segment. And so as we go through the next segment of the final segment of this presentation, we will start off with a poll. So I invite you now to participate by taking this poll just to find out what your thinking is in regards to communication in the mathematics classroom. So there are just 4 true or false questions that we will be using for this poll. Go ahead and make your selection. All right, so far no one has responded as yet. Just one person have responded already. All right, it's going up. So we will be closing the poll in the next 10 seconds. All right, we will be ending the poll right now. Thank you so much for participating. And based on the responses given in the poll, it is quite evident that there are varied views regarding what communication in the mathematics classroom should look like. However, I hope that as we go through this segment of the presentation, we can have a mutual understanding regarding effective communication in the mathematics classroom, and also to have a better appreciation as to the role that communication play while solving problems in the mathematics classroom. So thank you so much for participating in the poll. All right, so as we go further into this segment, I want you to share with me what you think communication in the mathematics classroom should look like. You can go ahead by raising your hand. We'll allow you to speak, or you can place your responses in the chat.
Mrs. Cohun, Alicia Britt has raised her hand. I'm going to unmute her mic.
Go ahead, Miss Brett.
Okay, good afternoon again. Okay,
good afternoon.
So communication, when communicating in the mathematics classroom, it should be precise and clear. So students should understand exactly what you're saying. So it should be precise and clear to the students.
Thank you so much. And I liked how you emphasize precise and clear, because that is what it really should be in the mathematics classroom. Do we have any responses in the chat, Ms. Tennant?
Not at this time.
Gail raised his hand. We'll allow him to speak. Go ahead, Mr. Gale.
Communication in mathematics classroom, as colleague said earlier, instructions should be clear, but students should also be given the opportunity to explain their reason for giving a particular response. Because sometimes we, the teachers, might be looking at the problem from one angle, but because we're the facilitators, that may be the case, but because the students are the persons who will be solving the problem, then they will be seen from different angles, and so they should be able to justify their responses.
Thank you so much, Mr. Gale. And I agree with that response. Indeed, while students are exploring mathematical concepts and sharing ideas, they need to give justification for those responses. So communication is quite vital in any mathematics classroom because it's basically where we have rich discussions happening, where the teacher acts as facilitator, ensuring that the correct probing questions are asked. Students are able to share their responses, giving justifications. As students listen to others respond, they will also be able to clarify their own thinking. If they are having misunderstandings after hearing the different responses that are shared and the different justifications, they are now able to adjust their own thinking based on the concepts being explored. So it is quite important to have effective communication happening within any mathematics classroom.
Before you move on, the chat, Dion Francis is saying, accept all answers as each answer can be justified. Janelle Porter, I believe communication is two-sided. Students share their ideas and the teacher guides students with precise instruction. Donor Grace saying meaningful, engaging, interactive, and clear, as well as Sandra Williams, simple everyday language and things should be used so they can relate.
Thank you so much. So students at this grades 1 to 3 grade level, they need to be sharing their responses in a clear and precise way, as you would have said. And effective communication in the mathematics classroom, I'm sure you will agree with me that it will reinforce literacy skills. Now, as we have communication happening within the mathematics classroom, students indeed need to play their role for there to be a rich discussion. Now, in regards to the students' role, there is a direct link to the role that the students play and the students' mathematical practices. So we will be identifying the two main practices from the 8 practices that are directly linked to the students' role within the mathematics classroom. And this first one we will be looking at is math practice 3, where students are able to explain their thinking and respond to the mathematical thinking of others. So while they are solving problems, they can explain their strategies using drawings or models or examples. They are able to share what they would have done in a precise way. In addition to that, they are able to compare strategies that students in their own class would have shared. They are in a position where they can ask some questions in order to clarify their own thinking and make connections. Let us look at another example just to see how this practice plays out within a typical classroom. So here we have a situation where the teacher would have given students an activity where they show quarters. Now we have these 2 students, Alex and Jack, who would have provided their responses based on what you're seeing on the screen. So look at Alex's representation. So she would have represented her quarters like that. In addition to that, she is justifying why she thinks that she would have divided that shape into quarters. So Alex is sharing that thinking. She's saying that that shape, my shape, shows quarters because it has 4 equal parts. And then now we have Jack. This is how Jack would have shown, provided his response based on his own understanding. And he is also giving a reason why he thinks he would have done the representation correctly. So he's thinking that my shape shows quarters because it has 4 parts. No, it is the responsibility of the teacher at this point to pull on the student's representation, because it is quite clear that Jack is having misconceptions in regards to representing quarters. So using that student's incorrect thinking, there can be a rich discussion in order to get students to say why they think Jack wouldn't have represented quarters correctly. Now, as we go to another math practice, still speaking to the student's role, we want to highlight math practice 6. And it is basically what you would have shared before, where you mentioned that students use clear, precise language when they are sharing their ideas. So when students solve problems, we want them to do so in an efficient and accurate manner. While they are solving, they are checking to see if what they are doing is making sense. Is my answer matching up to the problem I am trying to solve? And when they are through using those different strategies, they are able to explain, they are able to share those views accurately. They are able to use the correct words, the correct symbols, and different units of measure. And now we will examine another example of this happening in the math classroom. So let us look at this task. All right. So Dora was given the task to shade a half of her shape. This is what she shades. All right. Now I am going to invite you to tell me something that you think Dora would have said, just to explain her thinking and explain her representation, the representation that she would have made to show that she would have shaded a half of her shape. So I'm going to allow you now to share. You can raise your hand, we'll acknowledge you, or you can place your responses in the chat. What are some of the responses you think Dora could give just to justify her representation? Do we have anyone responding as yet, Miss Tennant?
Not as yet.
I see Modisha Wright raised the hand. We'll allow her to share at this time. Go ahead.
Good afternoon, colleagues.
Good afternoon.
All right. I think Dora would say that there are 12 squares, 3, 6, 9, and she shaded 6 of the 12 squares. So she shaded a half of the.
Thank you so much for that point. Do we have any other responses?
Would also like to talk. So I'm going to open his mic.
All right, so as the colleague just said, the shape, even though it is a rectangle, it has 12 parts. So literally, Dora here is not finding the half of the shape, but the half of a group of things, which is 12 rectangles within another rectangle. So shading 6 out of 12 is actually shading a half. Sometimes we teach to find the fractions of a shape, and so when transferring fractions to group of things, then students tend to be confused. But what Dora has done here is actually demonstrated that she can find the half of a group.
Thank you so much. I love how you put it. Well said,
So
well said. Thank you.
The chat is
Yes,
lighting up. Let me read some of the responses from the chat.
go
Peter
ahead.
Gay Fletcher says the shape is divided into 12 parts and she shaded 6. Half of 12 is 6. Tashna Gay, 6 is half of 12. Alicia Britt, she counted the squares, then divided by 2. Judin Ibanks, shade 6 parts out of 12. Tasha Brown, she could shade 6 of them. Therese Powell Thompson, Miss have 6 shaded and 6 not shaded. Monique Smith, half of 12 is 6, so she did that. Sandra Williams, I shade every other space to make sure they're evenly shaded. Miss Richmond, 12 equal parts, 6 shaded, and Faith Phillips says, I think Dora counted, which is 12 all, and then shade 6.
Thank you so much. That's a mouthful. All right, so I agree with all of those comments, and that is how we want students to be precise, justifying their representations. Now, the students have a role to play, and also us as teachers. All right, and so the role that we play, it is directly linked to the teachers' mathematical practices. Now, there are 4 main practices that are directly linked to effective communication in the mathematics classroom. So we have use and connect mathematical representations. So this is where we give students problems to solve. It's where the teacher allows students to solve problems using different strategies, using different representations, using models. So remember the birdcage problem that was shared earlier, where there were 12 birds to be placed in cages, and each cage having the same number of birds. So here students were given the opportunity, based on the task given, to show different representations. So even at home, students could choose to use stones or bottle covers in order to do their representations, and even take pictures of these representations, send it to the WhatsApp group, and there could be a discussion regarding what they would have represented there. Now we have our second practice that speaks to teachers facilitating meaningful mathematics discourse within the classroom. So this is basically driven by the teacher asking these probing questions to pull from students what they are thinking, getting students to share their responses, getting them to give justifications, asking probing questions so that connections are made as students show different representations. Now, we want to focus on purposeful questions. Now, it is very important for the teacher to assume this role, where purposeful questions are asked so that when students are given problems to solve, they don't become stuck. Because sometimes we do not give students problems to solve because we think that students at this grade level, they cannot manage it. But these probing questions will help the students to put a foot in to solving the problem. Keep on asking the questions, and the students will be able to think of different ways based on the question and what it is activating within their minds will help them to indeed solve these problems. Now, let us think back at the task where the students were asked to show quarters. All right. So the teacher could have asked, why did you divide the shape this way? What does each part represent? And I think some of these same questions were shared in the chat. Can you give each part a name if the parts are unequal? How can you tell if each part is a quarter? Now, as you get students to share their responses, you can assist them by using what we call prompts. So asking them a question, for example, let us go back to the first one I shared where I said, why did you divide the shape this way? Then the teacher can now prompt the student, I divide the shape this way because, and they add why they are thinking or what they are thinking. Now, we also want to elicit and use evidence of students' thinking. And we do so again by the questions that we pose. So for the task where students were asked to show or represent quarters, in comparing Alex and Jack's representation, the teacher could ask students to share what is same or what is different about the representation, and for students to agree or disagree and just disagree or disagree to the representations that were provided, and also to give their justifications. So these are the 4 practices that support effective communication within the mathematics classroom. Now, what drives communication in the mathematics classroom? Here again, I allow you to share. So you can place your responses in the chat, or you can indicate by raising your hand and we allow you to speak. What do you think drives communication in the mathematics classroom? Madisha Wright raised the hand. We'll allow you to speak. Go ahead, Miss Wright.
As we have been establishing throughout the discussion, that of probing questions. So there's no quote unquote right or wrong answer. We have to allow for the students to think critically. And so we can't just come with an answer to say this is the correct one. And we have to allow them to, you know, say what they think and explore other options, and to, you know, explain to them, use the mathematical concepts, and, you know, get them to get us as a class, students and teachers, to agree or to say, okay, based on this mathematical concept, this is correct, this may not be correct. Why is this correct? Because a square must be this, that has, a square must has, like, for example, a square must have 4 equal sides, whatever it is. We can come to an agreement based on different options, but we can't just stick to one thing. The classroom is not like that anymore. It's diverse. And so we can accept what they say, and then we can discuss to say why this is so, why this may not be so, you know, and that sort of thing. So probing questions that will bring about discussion, as it was shown in the different, I think when the parts were divided into 4, or the students divided them differently, that was a good way of bringing out communication, asking, why do you think Alex divided his shape this way? Why did the other child do this? Why did, and not just at all times doing it the way the first child did it, to say that's the only correct way. So things like those, making it, making the symbols in a way that brings about questioning and answering, and bringing about discussion, you know, that sort of thing, if you understand what I'm saying.
Thank you so much. So you would have summed it all up nicely. So it is basically you giving, providing the rich experience within the mathematics classroom. And in order for, Go ahead, Miss.
There are some
Timmons.
chats. There are some messages in the chat.
Yes,
so,
go ahead.
Miss Levy saying teachers' attitude towards the subject and the students. Miss Prince, open-ended questions. Patricia Adams, probing questions. Narda Roy, probing question drives communication. Samantha Mackenzie, presenting the students with different scenarios and asking them open-ended questions. Tasha Brown, students can reflect and clarify their ideas. Annette Robinson, when a task is given and the students have to come up with different ways to solve. Rose, a good teacher-student relationship. If the teacher is not welcoming, then students will hold back. And Faith Phillips says, each shall see and understand differently. So it is allow the students to getting other students to participate and helping them to bring out the critical thinking skills.
Thank you so much, Ms. Tennant. So it is basically the teacher creating that rich problem-solving experience within the classroom so that students can actually have something to talk or to write about. Thank you so much for those wonderful points. Now, as we go further into sharing some strategies that you can use to improve communication within your math lessons, we will be using this task to do our explorations, all right? So this is a problem-solving task that we are working with. It says, while teaching this objective, identify and name basic shapes, describing and classifying shapes. Mrs. Smith gave her students the following task as an exploratory activity. And the instruction to the students was group the shapes in different ways, justify your response. Now, this is a task that we will be using as we explore the different strategies that you can use within your mathematics classroom to improve communication. So let's go. Now, the first strategy that we want to highlight is the think aloud strategy. Now, what is this strategy all about? Again, I want you to tell me. I think you have some understanding in regard to this strategy. So I want you to indicate by raising your hand or even place your responses in the chat. Tell us what you think the Think Aloud strategy is all about. I see Denise Palmer raised hand. Go ahead, Ms. Palmer. What is the Think Aloud strategy all about? What does it entail?
It asks the students to say out loud what they're thinking, like when they're solving math problems or responding to questions posed by the teacher or other students.
Thank you so much.
Let's go with Melissa Smart.
That's it. Yes.
Melissa Smart would like to share.
Go ahead, Miss Smart.
Never mind, my hand was raised for the previous question before this one.
Okay, thank you so much.
Okay,
all right, so it is, yes.
And Collins would like to share as well. And the chat is also lighting up. So
Collins,
you share.
Go ahead. Do we have any responses in the chat?
Yes, so Twain Wallace is saying, discuss how you would solve the problems orally. Tasha Brown saying what you are thinking aloud. Gloria Wilson Anderson say whatever comes to mind. Rose is saying the think aloud strategy is the teacher modeling his or her thought process of problems. Dennis Lewis, this is where you ask students to say what they think about a specific topic. Foster is saying allowing the students to orally state what they're thinking and share their ideas with other students. Patrice Lindo talking through the details of the problem, decisions they have made, and the reasoning behind their decisions.
Thank you so much. So you're on point. You're all on point. So it is basically thinking out loud when you are solving problems or when you are responding to questions posed by you, the teacher, or between students. Now, the think aloud strategy is quite important, especially as we navigate the online platform. And we want to ensure that as we pose problems to students, they can think out loud, they can model this strategy in order to arrive at a solution. So if while we are engaging students, we seek to build this skill, they can use it when they are at home solving problems. So it is a versatile strategy. Not only can it be used at school, but at home as students solve problems while at home. Now let us think back at our task, and we want to model the think aloud strategy for this task. All right, so let me remind you what this task is all about. While teaching this objective, identify and name basic shapes, describing and classifying shapes, Mrs. Smith gave her students the following task as an exploratory activity. And the students were asked to group the shapes in the different ways, justify your response. So I want us to know, be the students, and I want you to model the think aloud strategy as you solve this problem. Again,
yeah, Brett has raised her hands.
Yes, go ahead, Miss Brett.
Okay, good evening again. Okay, so I would group the squares and the triangles together because they have sides, but the circles do not have any sides.
Okay, thank you. So that is a display of the student thinking out loud while solving this problem. Thank you. Do we have any other response?
Melissa Smart and Modisha Wright would also like to talk.
Go ahead, Miss Smart.
Okay, so I would group them according to color. So I will put all the green shapes together, all the yellow shapes together, and all the red shapes together.
Wonderful. Thank you so much. Miss Wright? If not, Miss Wright, do we have any other responses in the chat?
Okay, from the chat, we have a lot of responses. Group according to colors. Majority of the persons are saying group according to colors. Nicole Martin is saying I would group them according to colors, red, yellow, green. Brissett Thompson Elliott is saying I would group according to colors, so there are 4 in each group. Peter Gay Fletcher is saying we could also group them by the number of sides.
Remember now, thank you so much, Miss Tennant. Remember now that when you model the think aloud strategies, basically you, while working through the problem, you are thinking out loud what you are to do when solving this problem. Now let us look at a student's response. So this is how a student responded. This is an example of how the think aloud strategy was utilized. So she's saying, I can put the shapes with the same color in a box. The 2 green triangles, green square, and green circle will be placed together. So as she is solving the problem, she is thinking out loud and she is modeling, she is solving the problem and she's justifying her groupings. Now, effective communication in the mathematics classroom involves the teacher posing purposeful questions, as was said before. And so we will be looking at this same task, and I want us to now come up with some questions that you could ask to generate a rich discussion in your classroom as students explore this same task, asking them to group the shapes in different ways and for them to justify their response. What are some questions you could ask in order to generate a rich discussion as the students explore this task? So again, I invite you to raise your hand. We'll allow you to speak, or you can place your responses in the chat. Some questions that you could ask.
There is no response as yet. So Amelia Campbell Nelson. Wait, Amelia Campbell Nelson. Okay.
She shared a response in the chat.
What do you notice about the shapes? Tasha Brown. How would you group these? Alicia Britt, similarities and differences. Samantha Mackenzie. How many triangles are there? Denise Dixon Bramwell, how many shapes are there altogether? Karen Green Lawrence, how can you group the shapes? Patricia Adams, how can you group these shapes? Denise Dixon, what color are the shapes? And Samantha Mackenzie, how many red shapes are there? Denise Palmer is also asking, what are 3 types of shapes?
Okay, thank you so much for those responses. Let us look at some sample questions in addition to what you would have shared. Now, we want to show you, give you some examples of questions and also prompts that you could give to students while they respond to these questions. So the first question, how did you group the shapes? So in getting students at this grade level to get into the habit of communicating their responses, you can give this prompt that says, I group the shapes by, and they tell you what they would have done. Why did you group them this way? And a prompt that could be shared with them just to get them to speak. I grouped these shapes together because, and they share what they would have done. What other way could the shapes be grouped? And again, prompt, the shapes could be grouped by, and they add to that. So it's like we are scaffolding them, because we know that students at this grade level, they don't readily communicate their ideas. But by giving them these prompts as a starter, we can get them to start talking more in our mathematics classroom. Now, as we wind down, we want to highlight this as well. Engaging students in activities where they identify errors in students' thinking and put forward arguments supporting their claim. So this is also a way for us to promote effective communication within our mathematics classroom. Now let us look back at this task. So based on the task given, this child is thinking that the circles are placed together because they have one side. The squares are placed together because they have 4 sides. The triangles are placed together because they have 3 sides. Now, how could a discussion assist this child in correcting the misconception identified? What are some questions we could ask just to get the discussion going and for the child to correct the misconception here? So while you share, I want you to highlight what the misconception is, and then I want you to now share some questions that you would pose to the students in order for them to alleviate this misconception.
Mrs. Kawoon. Marjorie Monroe Walters would like to speak.
Go ahead, Mrs. Walters. If not, do we have another person? I think I saw Brett.
No, but the chat is lighting up. They're saying, which group has less? How can you group the groups equally? No, misconception, circles have no sides. And Prince is saying, what type of lines used to draw each shape?
Thank you for those responses. Remember now that the question should be for this posed so that the students can get an understanding as to why circles do not have sides. Do we have any other response as to the questions that we could ask just to clarify that misunderstanding?
Danae Smith would like to speak.
Go ahead, Miss Smith.
Miss, you could, if you have already thought about lines, curved lines, straight, vertical, horizontal, you could go back to that knowledge with them to find out what lines are. And then if, for instance, you have your concrete object with them, if they have a math kit, you can allow them to take their circle out of their math kit and compare their knowledge of vertical and horizontal lines and curved lines as well. And then they could compare to see if their circle from their math kit has any line.
Okay, thank you for that response. So we don't normally refer to the curved lines as a side. All right, thank you so much.
Before you move on.
Yes?
Nicole Martin, misconception is that a circle has no side. A question that could be asked is if a circle has an edge or vertex.
All right, I like that point. All right, thank you so much for your responses. Thank you so much. And we are coming down now in class for practice. These are some recommendations that we want you to take away. Now, effective communication within the mathematics classroom, as you would have said, as you would have agreed with, involves students explaining, involving them justifying verbally through the rich conversations that you have within your math lessons. So we are recommending that you continue along that vein and also to utilize these different strategies in order to improve on communication within your math classroom. Now, as students communicate their ideas, we also want them to be able to record or write these justifications in a clear and precise way. Now, students at this grade level, they are more oral. However, we want to bring them from just saying things out loud, but we also want to give them the practice to write down these justifications as well. Now, we want to look at the final strategy, and it is the notice and wonder routine. And you would have been introduced to it before, where we looked at the pizza in the engagement activity in the problem solving segment. And it is basically just you providing an image or video, a graph, just a stimulus that will get students to share what they notice, what they are thinking when they see this picture, and what comes to mind as they look at it. And it is a versatile routine because, as you see, it was used for the engage activity, and it can also be used just for an activity that gets students curious, get them to reason. The probing questions that you ask will help them to analyze and think while they are solving problems. Now we will look back at our task where we were to group the shapes in different ways, and we will see how the notice and wonder routine can be linked to this same activity. So again, I want you to just act as if you're the students, and I want you to share what you notice. What comes to mind? What do you notice? What are you thinking when you see this picture?
Monisha Wright would like.
Go ahead, Miss Wright.
I noticed that there are different colors, Miss.
Thank you so much. Do we have any other response?
Nelson, number, shape, colors. Denise Dixon Bramwell, all shape has 3 colors. Galaxy Tab A would like to share something.
Go ahead, Galaxy Tab A. If not, is there any other person in the chat?
Yes, in the chat. Richards, each set go up by 1. Dion Salki Francis, number 534. Faye Phillips, I noticed that one of the same color is in each box.
All right, so those are some things that you would have noticed, you would have seen. All right, so what are some things that you are wondering about when you look at this picture?
Tanisha Hines, well, she's answering the notice question. I noticed that the shapes that are the same are grouped together. All the shapes have the same color. Noblet Neil, there are different numbers in each. Carla Dennis, why the shapes are grouped? Why are there different shapes? Why are there different numbers?
All right, wonderful. So here we see that we can generate curiosity in students by using the notice and wonder routine. And based on the concept that we are exploring, this curiosity will now help them to get a richer experience as you go deeper into the concept. Now, the notice and wonder routine is quite important. As was said before, it really helps students to reason, to come up with different ways and different strategies for tackling a problem, because it's generating some questions within their minds, and it gets them thinking and to start wondering about what they can do in order to solve a problem. And so as we tie up this segment of the presentation, I want to reinforce the fact that communication plays a vital role in the teaching and learning experience, as you all agree with. It enriches the learning experience by giving students the opportunity to share their ideas, to critique the reasoning of others, to justify responses, and by the use of probing questions, students are able to make connections. They are able to discover concepts, and they are able to communicate with or amongst themselves while solving problems. So I encourage you, us as teachers, to ensure that we have effective communication happening within our classes. So even though we are at the grades 1 to 3 level, and we can get students to talk, we also want to encourage them to write down these, what they are thinking, get them into the habit to record, to write, to simple language, use simple language that they know at their level in order to justify and their responses. So I thank you so much for participating so well for this segment. And as we tie up, as we pull the curtains down, I invite Mr. Williams just to do the final, take the finals.
Thank you, Ms. Cahoon. As we wrap up our sessions, colleague, I know you are exhausted and we have one final poll for you to do. Now, this is going to be about 30 seconds or so, and I would appreciate if everyone respond to this poll.